Hi everyone, welcome back. Welcome to Mihitha Academy. As part of this episode, let us understand octal number systems in detail. As part of this episode, we will understand what exactly is an octal number system, how can we represent any decimal number in an octal number format. Also, we will see how can we convert a number from decimal number system to octal number system. At the same time, we will also see how can we convert the number from octal number system to decimal or octal number to binary. Okay, come on guys, let us start today's episode. So coming to the overview of octal number system, as we can see over here, with the increase in value of a decimal number, the number of bits zeros and 1 in binary representation also increases. We also know what exactly is a binary representation? Zeros or ones, correct? But if you are representing decimal number 1 or 2, it need only 1 bit length, correct? Whereas if you are mentioning some millions of value, or for example 10,000, to represent 10,000 decimal value to in binary, it really required lengthy binary digits, correct? So how can we minimize that? In that process, there are multiple types of other number systems evolved. Those are called octal number system, and also one more famous number system which is widely used called hexadecimal number system also. As part of this episode, let us focus on octal number system. In the subsequent version, we will see the hexadecimal number system. Also, if any of you has not watched the binary number system videos yet, you can go ahead and watch that video so that you will have more clarity on the binary number system. Coming back, so with the increase in the decimal value, obviously there are more number of bits needed. That's the reason there was a need for newer type of number systems needed. That's the reason this octal and hexadecimal number system arose. Then the next point, if you have to see, octal number system was devised for compact representation of binary numbers. Clear? Meaning, yeah, instead of representing a single number in a binary form with a series of zeros and 1, we can reduce the length. So octal number system is also called as base 8. If you remember, binary number system is called base 2. Correct guys? This one is called base 8. So similarly, if you see an example, you see over here 273 to the base 8, meaning this is a number in an octal number format. 14 to the base 8, 615.23 to the base 8. Clear? So if you have to see the next point, position values are expressed in the power of 2 to the power of 8. Okay, power of 8 powers. Clear? In case of binary number system, we were using power of 2 because 2 was the base in binary number system. In the octal number system, base is 8. 3 binary digits are sufficient to represent any octal digits. Okay, so we know the octal number systems, it has total 8 digits starting from 0 to 7, correct? So in order to represent this in binary form, zeros and 1, combination of zeros and 1s, we need 2 to the power of 3, which is nothing but 3 digits in binary form, which is only 3 digits is sufficient to represent any number, any of the octal digits. Okay, so now this particular slide or this particular image will tell us octal values for 0 to 7 digits for the decimal number system. Okay, so we have a decimal numbers starting from 0 to 7, and we have equivalent binary values and octal digits. In octal number system, 0 to 7 remains same. Decimal number also equivalent will be 7. But if I have to represent this octal number in an equivalent binary form, 0 is represented as 0, 0, 0, 1 is represented as 1, 2 is represented as 0, 1, 0, 3 is represented as 0, 1, 1, 4 is represented as 1, 0, 0, and 5 is represented as 1, 0, 1, 6 is represented as 1, 1, 0, 7 is represented as 1, 1, 1. Got it? So now let us focus and learn a new concept, a very important concept. How can we convert or conversion of a decimal number okay, to an octal number. We'll see how can we convert decimal number to a octal number. For example, if there is a decimal number given, let us understand how can we convert, or what are the steps to be followed to convert that into octal number system. Okay. So if you see these are the different steps which you are supposed to follow to convert a given decimal to octal number system, which is exactly same as even the binary number system also, but here the base value would be 8. Okay, so if you see the step 1, divide a given decimal number by base value, which is 8, of the number system in which it is to be converted. In case of octal number system, the base value is 8, so we have to divide a given number by 8 and we have to note down the remainder. Step 2, then we have to keep on dividing the quotient of the previous step by base value, which is 8, and note down the remainder till the quotient is 0. Okay, this is very, very important. First step is we have to divide a given number by 8, and then we have to note down a remainder. If the quotient is not 0, we have to keep dividing the value by 8, repeat the steps and keep noting the remainder till your quotient value becomes 0. Okay, then write a noted remainder in a reverse order. Okay, from the bottom to top to get a equivalent octal number. Okay, so pause the video, read through the steps. You'll be able to understand the steps in detail. However, let us see each of the step in detail in the next video. Okay, let us take an example. Convert a decimal number 65 into a octal number 8. Okay, so if you see over here, we have 65, the value or the decimal number has been given. We have to convert this 65 into equivalent octal value, base 8 value. So let us start our process. So in the right hand side, for your better understanding, I have also given 8 tables. Okay, so that you will be able to find out what is the remainder easily for learning purpose. However, you guys at this stage you know tables 8, 9, 10 and all, right? You can also note down a table 8 somewhere at the worksheet or section of your worksheet, so that you can easily solve any of these kind of examples. So let us write down 65, the given number. I have to divide this by 8. So if I have to divide this 65 by 8, how many times I can? 6 is not divisible, but if I consider both the number, 8 it's a 64, correct? So what I can write over here, 8 is a 64 and the remainder is 1. Okay, and now I can take this 8 again and I can divide this 8 by 1, correct? 8 ones are 8, remainder is 0, correct? Now again try to divide this 8 because the quotient is not 0. The quotient would be 0 and remainder is 1. The value of 65 in the octal number system would be 101. I have to write down the value from bottom to top, the remainder. So 65 in decimal number system will be equivalent to 1. This is the 1, 0, this is the 0 and 1. This is the 1 to the base 8. Clear? This is the answer. Got it, guys? So let us move on and understand one more example. Okay, so convert a decimal number. What is the decimal number given? 112 to the base 10 to an equivalent octal number. 122 is the given number. Okay, so now let us try to convert this into octal number. So 122 is the given number. I have to start dividing this number by 8. I can divide 12. 8 ones are 8. Remainder is what? 4. 42. 8 5s are 40. Remainder is 2. Got it, guys? It's a simple division operation. Now let us take 8 again. 8 ones are 8. The remainder would be 7. Then take 8 again. Because the quotient is not 0, we have to repeat the division process. 0, the remainder is 1. So now if we have to write down the equivalent of 122 in an octal form is 172 to the base 8. Got it, guys? Very simple. 122 in the decimal would be equivalent to 172 in the octal number system. Hopefully this particular example is also clear. Let us move on and understand a given. If you remember few minutes back we have seen a table. This is the octal digit, this is the decimal digit, this is the equivalent binary digits, correct? So maybe let us take one more example, which is maybe 23 somewhere here. 23 in this decimal, what would be the equivalent value in octal number system? Okay, so again follow the same process. 23, start dividing this by 8. 8 2s are 16. Remainder is 7. Then 8, start dividing because quotient is not 0. Quotient is 0 and value is 2. So I have to write down the remainder in the reverse order. 27 base 8 would be the answer. Clear, guys? This is the equivalent of 23. Okay. So now let us move on and understand one more important concept, which is conversion of octal number to a decimal number. Assume that they have given octal number to you. They are asking you to convert into decimal number. How can we do that? Very simple. Conversion from other number system to a decimal number. In our case, the source number system is octal number system. If you see the step 1 over here, write the position of a number for each alpha numeric symbol in the given number. We have to write down the position number. Then get the positional value for each of the symbol by raising its position number to the base value, okay, of a given number. We have to find out the positional value. This is very, very important, okay. First position number we have to write, then position value we have to write by raising the given number, by raising the position of a number to the base value, then multiply each digit with the respective positional value. Given digit is there, you have to calculate the positional value, you have to multiply that, then add all these decimal value to get a equivalent decimal numbers. Okay, don't worry, steps may seems complex. Pause the video, read through that. However, now we will see the same step and apply those steps to convert a given octal number to a decimal number. Okay, let us take an example. 257 base 8. 257 is in octal number system. We have to convert this guy to decimal number. So write down the digit. The digit, if you see, 257. What is the position value? This is 0, this is 1, and this is 2. Okay, and now I have to position number. This is 0 1 2. This start with 0 position, first position, second position. This is the given digit. Okay, 257 is there over here, right? That is exactly same as this. Okay, so now I have given a positional value 0 1 2. I have to calculate the positional value. Positional value base is what? 8 to the power of 0, 8 to the power of 1, and 8 to the power of 2. Okay, and now the equivalent decimal number. In order to get the decimal number, what I have to do? I have to multiply given digit 2, this 2, with the positional value 8 square plus 5, given digit 5 into 8 to the power of 1 plus 7 into 8 to the power of 0. Clear, guys? So now if you have to calculate this, 2 into 8 into 8. 8 square means what? You also know 8 square is 64, correct? 5 into 8 plus 7 into 8 to the power of 0 is 1. Here 8 to the power of 1 is 8. So 8 8 is 64 into 2, 128 plus 8 5 is 40 plus 7, 7 ones are 7. This has become this has become this, and this has become this. 128 plus 40 is 168. Addition of this plus 7. 175 is the right answer in a decimal number system. Got it, guys? So let us understand one more example, which is we have 111 in decimal format, octal format. Let us understand how can we convert it into a decimal format. Decimal is nothing but base 10. Okay. So first let us write down the digit 1 1 1 and the position value 0 1 2. Position number, position value would be 8 to the power of 0, 8 to the power of 1 and 8 to the power of 2. So we have to multiply this digit with the position value. 1 into 8 square plus this 1 into 8 to the power of 1 plus 1 into 8 to the power of 0. Okay, which is 1 into 64. 8 square is 64 plus 1 into 8 plus 1. 64 plus 8 plus 1, which is 64 plus 8 is 72 plus 1, 73. 73 in base 10 is equivalent value of 111 in base 8. Clear, guys? Hopefully you guys are clear with this example. Let us move on. Hope you like this video. To support us and our effort, you can scan this QR code and make a donation. Thank you. And understand one more important conversion. So far what we have seen how can we convert decimal number to an octal number. Now let us understand how can we convert octal number to a equivalent binary numbers. So if you remember in the first slide we have seen what is the octal number and what is the equivalent decimal number and what is the equivalent binary number. Now let us understand how can we convert octal number to an equivalent binary numbers. Given binary octal number to a binary number. Given a binary number, an equivalent octal number can be represented by 3 bits. Bits are nothing but what? Zeros and ones. Okay, guys. 3 bits is computed by grouping 3 bits from the right to left and replacing each 3 bit group by the corresponding octal digits. Okay. So convert given octal number to a binary number. So what does that mean? Let us go over here and take this example. Okay. What is the octal number? 705. If you remember, there is a table we have prepared earlier, right? 0, this is octal number, equivalent binary number. What is the binary equivalent of 5? 101. Write down that number 101. Followed by what is the equivalent of 0 in binary? 3 times you have to write 3 digits 0. For 7 it is 111. 111. So this is the binary equivalent of octal value. Got it, guys? So all we have to do is we have to group this 0 0 0 1 0 1. This is the binary equivalent of your 705. Similarly, let us see one more example. 613. Convert a given octal number to a binary number. First what we have to do, octal number 613. This is an octal number system. If you have to convert 3 to the equivalent binary number, 3 is what? 011. You see 3 is equal to 011. 1 is nothing but 001. 6 is nothing but 110. 110. Okay. So this is the equivalent value of a binary number. 110, 001, 011, to the base 2. Clear guys? Hopefully you guys got to know how can we convert a given octal number to a binary number. So let us see one more last scenario. How can we convert a given binary number to a octal number? Okay, assume that they have given a binary number which is series of zeros and ones, and see how can we convert that into a octal number. So for example, you see over here they have given a binary number which is 101110. So we have to convert that into octal number. All we have to do is from the right hand side, rightmost digit, we have to write 3 binary bits 0, 1, 1. Okay, and then 1, 0, 1. You have to write in a group of 3 bits. Okay, starting from here to here, starting from here to here. So now refer this table. 110 is equivalent to what? 110 in binary is equivalent to octal number 6. Similarly, 101 is equivalent to octal number 5. 101, here we have 101, it is equivalent to octal number 5. 56 to the base 8 is equivalent of this number. All we have to do is we have to group the number bits, binary bits, in a group of 3 starting from right to left, and then refer this table and write on the equivalent octal value. Similarly, we have one more example which is this. So what we have to do, we have to group into 3 digits. Okay, 0, 1, 1. First group, this is the first group. And the second group is 1, 0, 0. The third group is 1, 1, 1. So the equivalent of this, if you refer this table, 6. 6, 0, 0, 1 is 1, and 1, 1, 1 is 7. 716 is the octal equivalent of this binary number. Got it? Very, very simple, guys. So hopefully as part of this video, you guys have understood what exactly is an octal number system, how can we convert a value given decimal number to a octal number, given octal number to a decimal number. Also we have seen how can we convert given octal number to a binary number system, and also given binary number to a octal number system. Hopefully this particular video clarified all your doubts with respect to the octal number system. Hopefully you are liking this video, guys. If you like this video, please do subscribe to our YouTube channel. Also share this video information with your friends and other people who really wish to learn and become expert in this octal number system. Also please do subscribe to our YouTube channel so that you will get lot of learning from our channel related to maths, social science, even science, and other computer science related subjects which is there in your curriculum. Thank you so much, guys, and have a good one. Happy learning. Hope you like this video. To support us and our effort, you can scan this QR code and make a donation. Thank you.